So the question is, for the y, would we have to put in what we solved for in the explicit equation? And the answer is absolutely yes. That's exactly the point. So this is not a complete solution to a problem. We started with an implicit equation, we differentiated, and we got, in the end, also an implicit equation. It doesn't tell us what y is as a function of x. We have to go back to this formula to get the formula for x. So for example, well, let me give you an example here. So this is hides a degree of complexity of the problem, but it's a degree of complexity that we must live with here. So for example, at x equals 1, you can see that y equals 1 solves. That happens to be solves y to the 4th plus xy squared minus 2 is equal to 0. That's why I picked the 2, actually. So it would be 1 plus 1 minus 2 equals 0. I just wanted to have a convenient solution there to pull out of my hat at this point. So I did that. And so we now know that when x equals 1, y equals 1, so at 1, 1 along the curve, the slope is equal to what? Well, I have to plug in here minus 1 squared divided by 4 times 1 cubed plus 2 times 1 times 1. That's just plugging in that formula over there, which turns out to be minus 1/6. All right, so I can get it. On the other hand, but at, say, x equals 2, we're stuck using this formula star here to find y. Okay? Now, so let me just make 2 points about this, which are just philosophical points for you right now. The first is, when I promised you at the beginning of this class that we were going to be able to differentiate any function you know, I meant it very literally. What I meant is, if you know the function, we'll be able to give a formula for the derivative. If you don't know how to find the function, you'll have a lot of trouble finding the derivative. So we didn't make any promises that if you can't find the function, you will be able to find the derivative by some magic. That will never happen. And however complex the function is, a root of a 4th degree polynomial can be a pretty complicated function of the coefficients. We're stuck with this degree of complexity in the problem. But the big advantage of this method, notice, is that although we've had to find star, we had to find this formula star, and there are many other ways of doing these things numerically, by the way, which we'll learn later. So there's a good method for doing it numerically. Although we had to find star, we never had to differentiate it. We had a fast way of getting the slope. So we needed to know what x and y were, but y prime we got by an algebraic formula in terms of the values here. So this is very fast for getting the slope once you know the point.